Alright, this is week 1, and we're going on to work on multiplying and dividing monomials. And this is really just more practice on the extra practice that I gave you for negative exponents and shortcuts. So hopefully you watch those extra practice videos, because I'm going to go through these kind of fast. Do stop the video and play it over to understand each piece if you need to. Alright, a definition first. A monomial is the product of numbers and variables. So what we have in each of these problems is one big monomial clump, a group of numbers and letters that are being all multiplied together. Look at this one. There's an invisible multiplication sign between the 2 and the z to the third power. There's invisible multiplication between the parentheses, invisible multiplication between the 5 and the z to the fourth power, and of course the powers mean that the z's are getting multiplied by themselves. So since it's all multiplication in all of these monomials, that means we can rearrange the factors being multiplied. I can put all the numbers first, the coefficients. I can go 2 times 5 first, and then I can go times z to the third times z to the fourth power. Just rearranging the order, don't need the parentheses anymore because they just mean multiply. These two multiplied make 10 times these two multiplied. I go back to my rules I learned in the last videos, and when I'm multiplying like bases, I just add the exponents. So z to the third power times z to the fourth power is z to the seventh power. We're too lazy to write the times sign in between, so the final answer is just 10z to the seventh power. Done. Alright, let's take a look at the next one. We're going to do the same thing again. We're going to reorder it with any of the coefficients. The numbers multiplied first, so 4 times negative 5 first, and then t to the fourth power, that one, times this one, t to the negative 5 power. Negative signs are important, folks, so don't forget the negative sign on the 5 here, this base 5, and the negative 5 here on this exponent. Alright, now we simplify. 4 times negative 5 is negative 20. T to the fourth power times t to the negative fifth power. Again, we've got two like bases, t and t. We just add the exponents. 4 plus negative 5 is t to the negative 1 power. And we're going to take this one a step further. We could stop here and say good enough, but we don't like negative exponents, especially if we have to put something in for the letter t and calculate this. It would be really hard to do in our head. So we're going to the party. We're going to create a quotient, a fraction, and we're going to decide who gets to stay up on top and who's got the negative attitude and needs to go downstairs. Negative 20 does not have a negative exponent. It's a negative number, but its exponent is just a plain 1 if you put one on it. So negative 20 can stay upstairs at the party. But t to the negative 1 power has that negative attitude, that negative exponent, so he's going downstairs. When he gets downstairs, he gets a better attitude, and it becomes t to the positive 1. Now, do we even need that exponent on t? Because this just means negative 20 over plain t. End of story. End of problem. Okay, let's take a look at the next one. Again, stop the video if you need to digest that or replay it. Okay, this monomial has everybody being raised to the second power. Everybody inside the parentheses gets this power. So the negative 2 gets that power, and so does w to the sixth power. So I'm going to rewrite this, putting that power on each of the factors inside. Negative 2, watch what I do though, putting it in parentheses. Whenever you're dealing with negative bases and powers, make sure you always put that negative number in parentheses so that if we decide to enter it in our calculator, that happens correctly. Alright, times w to the sixth power powered up to the second power, applying that 2 also to w to the sixth power. Let's simplify. Negative 2 to the second power, it means negative 2 multiplied twice. Negative 2 times negative 2 is positive 4. Negative times negative is positive. W to the 6th power raised to the 2nd power, we're raising a base to a power and then again to another power. That's our power rule. When raising a base to a power, then to another power, multiply those powers. W to the 6th squared is W to the 12th power. We are almost done. Let's just rewrite this without the times sign, and we get 4W to the 12th power. Done. Let's go on to the next one. This one won't be too bad because there's no powers outside of parentheses, so we don't have to apply powers to everybody inside. All we need to do is rearrange the factors, putting all the numbered coefficients first. So 2 times negative 4. And then all the letters, and we're going to put like letters next to each other. So this is an A times an A to the negative 3 power. Alright, now let's do the B's times B to the 3rd times B to the 4th power. Take a second to look at that to make sure you understand where I got each of the numbers and letters from. Alright, let's start to simplify. So 2 times negative 4 is negative 8. Positive times negative is a negative. Now 8 times A to the negative 3rd. That seems a little bit scary, but it's not really, because this A, you can always put a 1 there for the exponent. And when I multiply like bases, A and A are alike, I just add the exponents. So A to the 1, A to the negative 3, multiply, give me 1 plus negative 3, A to the negative 2. 1 plus negative 3 is negative 2. Times B to the 3rd power times B to the 4th power, add the exponents, get B to the 7th. Now we could leave it this way, but I don't like those bases with negative exponents, so we are going to the party. Let's get our upstairs, downstairs ready. Who gets to stay upstairs and who has to go downstairs? Negative 8 does not have a negative exponent. Remember, its exponent is an invisible 1. Negative 8 gets to stay upstairs. Negative 8 to the negative 2, that's got to go downstairs, and when he gets down there, that negative exponent becomes positive. B to the 7th power, he's okay upstairs. He's got a positive exponent. And this is the final desired answer. Okay? Alright, the next one is a little crowded, so I think I'm going to change colors so it contrasts. This time we have a monomial, a whole bunch of junk raised to the 2nd power. So in this one, we've got to make sure everybody inside those parentheses gets that power. So 3 has to get raised to the 2nd power, x squared has to get raised to the 2nd power, and y to the negative 3 has to get raised to the 2nd power. So let's rewrite this, distributing that power. 3 to the 2nd power times x squared, I'm going to put him in parentheses, to the 2nd power, times y to the negative 3 to the 2nd power. Simplify it. 3 squared is 3 times itself. 3 times 3 is 9. X squared raised to the power of 2. Power rule. Power up. So we multiply the exponents. X squared times the 2 times 2 makes x to the 4th power. Now if you accidentally added them, you'd just get the same answer, you'd luck out. But that won't work on this one because we need to make sure we multiply negative 3 times 2 and we get y to the negative 6. Alright, we've got a base with a negative exponent, so we will do one more step. We will go to the party. Who stays upstairs? 9, because his exponent is positive 1. X to the 4th power can stay upstairs, but y to the 6th power needs to go downstairs, and when he does, he gets that positive exponent. End of story. Last problem. Looks really complicated. It's really, really easy if you follow your rules. On the last problem, we just go back to our notes that say anything to the power of 0 is equal to 1. Look at all this garbage inside of here is all getting raised to the 0 power. So whatever this would condense down to, whatever it would calculate to once somebody tells us what W and X are, would end up being raised to the 0 power, and that would give us 1. The final answer on this is 1. Now I could go through all the steps and raise negative 17 to the 1 power, W, or to the 0 power I mean, W to the 11th to the 0 power, and X to the negative 9 to the 0 power. But even if I show you all the steps, you're still just going to get 1. Anything to the 0 power is 1.